Good morning. Glad to have you all here today. We can sit down and get the show going. It'd be great. I'm Hans Lombardo. I'm from Chain of Things, and we organized this event today. And Chain of Things was sort of started about 10, 11 months ago. We're a startup, and we saw the founders were sort of, there's some founders that were involved in Internet of Things and developing hardware, sensor systems for various projects, and we saw some of us were from the blockchain world, and we saw in a sort of nexus between blockchain and the Internet of Things, because the Internet of Things is very much a distributed sort of world, and we saw that blockchain is a distributed, basically, computing system. We saw that there's sort of a natural fit between the two. Also, as in terms of Internet of Things, sort of existential threat to Internet of Things, and machines, communicating with machines is security, and we saw blockchain as potentially being a great sort of solution for that. And so we've come up with various case studies. One of them is a chain of shipping to look at how blockchain and Internet of Things could actually sort of disrupt and innovate that industry. So, but I digress. I would like to introduce our first speaker, which is Jehan Chu, who is kind of a leader in the sort of blockchain world in Hong Kong. He was involved in Bitcoin at a very early stage, investor, and also he leads the Ethereum blockchain community in Hong Kong, and sort of a major evangelist of blockchain in Hong Kong. So, come on, Jehan.
Good morning, everyone. Thank you so much, Hans, Chain of Things, Connor, for having me today. I'm excited to be here because anytime we talk about blockchain, it's exciting. And anytime we start to talk about a new vertical or a new industry which is being folded into or being kind of reached by blockchain, I get super excited. But just to kind of take the temperature here, I don't want to assume that everybody's a blockchain expert, because even I'm not a blockchain expert. Can I just get a show of hands? I want to know, out of everybody in the audience, how many of you would you say are new to blockchain? Great, that's perfect, that's what I like to see. How many of you would say that you know a little bit or a fair bit about blockchain? Well, that's similar to the first part. Some of you are lying, either the first time or the second time. All right, so last one is, how many of you would say that you are very conversant and you understand blockchain at a high level? Okay, some of you raised your hands 3 times, so we'll just let that pass. Anyway, so just to kind of move this along, once again, my name is Jehan Chu, and I'm a partner, managing partner at Gen Advisors. Now, Gen Advisors is a blockchain blockchain-focused venture capital fund. So we only focus on blockchain. And we are a new fund. It's 3 partners. One is a guy from ex-HSBC for 16 years. Another has his own private equity firm here in Hong Kong. And we focus on blockchain. And we look at things like infrastructure, we look at things like platforms, and we look at things that are close to the base level and the building blocks of the blockchain industry. I'm a founding member of the Bitcoin Association of Hong Kong. If you are not a member of the Bitcoin Association of Hong Kong, I highly, highly encourage you to join. You can join either by going to our Facebook page or by going, more importantly, going to our Bitcoin meetup page. Meetup.com, interestingly, is one of the best places to learn about blockchain in Hong Kong. I'm also the founder of the Ethereum meetup, and we'll talk a little bit about what Ethereum is here in Hong Kong. I started that in 2014. And then finally, I also invest in coins myself. Companies, obviously, an advisor and an evangelist. I've been trying to talk to people about blockchain for years, and luckily, this year it seems like everybody's listening. I'll go back for a second, though, it seems to. Okay. the way that I like to kind of start with Bitcoin for those and blockchain for those of you who are new to the space is to first put aside this idea of what Bitcoin is. Bitcoin, in many ways, is a very, very beautiful and very, very intelligent distraction. And I say that because what Bitcoin basically is a calculator on top of a blockchain, okay? Now, let's just put that aside. Bitcoin is great for financial transactions, Bitcoin is great for transferring value, Bitcoin is great if you want to buy drugs on the deep web, okay? Fine, out of the way. Now, what's really interesting about this whole phenomenon and this whole movement that we're experiencing now, and why all of the financial institutions and why many insurers, and now why you are all in this room today, is you're really here because of blockchain. And blockchain is the underlying layer that underpins Bitcoin. Bitcoin was the first blockchain, it invented blockchain, but it is not the best expression of what blockchain can do. When I try to describe blockchain, what I like to say is that blockchain is the next layer of the internet. It's an additional layer on top of the internet, which helps do things that the internet doesn't do well. Things like security, things like identity, things like acute transfer of information in a trusted manner. That's what blockchain does. And like this says, it touches everything. For those of you who are at the back and can't see the screen, some of the points that are on this little kind of mind map are real estate, P2P payments, music, security, air traffic control, health records, intellectual property, machine learning, energy, food supply, driverless cars, personal identity, natural resources. So it really is quite a broad surface that blockchain can be applied to. And that's why I like to describe blockchain as a new layer of the internet. Because when I try to explain the scope of what blockchain can do, the way that I say it is that whatever touches the internet, the blockchain will touch. And ideally in a more secure and more efficient and frictionless way. So if you kind of take that as the departure point for the day, I think you'll start to be able to get your head around what we're really playing for those of us who are kind of looking at blockchain. Now, this particular day, set up by Chain of Things and Hans, is about shipping and bills of lading. So there's a very specific use case that you're going to be spending a lot of time today talking about. And it's an important use case. But don't forget about the wider kind of context, which is that although you're thinking about shipping and supply chain and chain of ownership and ways to secure movement of goods, actually underneath it all is this layer which connects everything else. So what exactly is blockchain? In a nutshell, it is software that provides decentralized kind of control or access. It provides immutable records and transactions, and it provides interoperable tokens. It does a lot of other stuff, but these are the things that I like to focus on. Now, at its root, blockchain really is just software. If I give you a Bitcoin, I'm not giving you anything. All I'm giving you is access to a certain entry on a ledger, and that ledger sits on the blockchain, and that blockchain sits out there somewhere in cyberspace in the cloud. But blockchain it really is software that kind of distributes the control mechanisms that is a slightly different paradigm than we're used to, both in society, in business, in government, and it's decentralized. From the beginning of time, we've organized our structures to be top-down and to be more command and control and more pyramid-like. Now, what blockchain is starting to do is actually provide a technological infrastructure and a piece of software which can help flatten out that pyramid-like structure. The way that it does that is through its architecture. Its architecture is quite simply a bunch of nodes which are running this piece of blockchain software. In some cases it's Bitcoin software, in some cases it's another kind of flavor like Ethereum. And every single copy of that software or that data which sits on that software is on every single node. So whereas in a centralized kind of situation, all the information sits in one silo, and that silo has a firewall around it. They try to protect that firewall, or they try to protect that data as much as possible. In the decentralized world, in the blockchain world, all data sits at all places at all times, and that's how you secure it. So this one kind of idea is quite important, not only to how the technology works, but to how people who are in this space think about things, very broadly, very horizontally, very distributed. So it really is this kind of mindset to get your head around. The second thing which is quite interesting about blockchain is that it provides a system for immutable records and transactions. And this, of course, is where it becomes really important for things like supply chain. If you are able to have a record, let's say a record from movement of an item from A to B, which can cryptographically or mathematically be proven to not be altered, and to be mathematically proven to have occurred at a certain time with a certain attached data like location, then that becomes really interesting. Because now you no longer have to trust your vendors, or the vendors no longer need to trust you. You actually just need to trust the code. And the code is transparent. It can be broken down and built back up, and you can formally verify it. Means you can mathematically prove that it's intact, and the integrity of both the data and the vehicle that the data is traveling on is intact. And that becomes your trust. So you no longer trust in people, you no longer trust in law, you no longer need to trust in relationships, you just trust the math. That's why this type of immutable record is quite interesting. Now, finally, and this is the area where I think that often sometimes gets lost when people talk about the opportunity of blockchain, there's something called interoperable tokens. Now, I've always found that interoperability is really the secret sauce of blockchain. What that means is, what blockchain is good at is being able to transfer data or information or transactions from a very, very disparate or very, very diverse set of actors who previously either could not connect or could not communicate, or it was too costly or inefficient or too much trouble to try and build the bridges that they needed to communicate. So what does that mean? One of the kind of base cases for blockchain is actually IoT, Internet of Things. Now, Internet of Things, if you're not familiar with the buzzword, is your watch talking to your car, talking to the electric grid, talking to your Tesla, talking to the air conditioning unit. It's everything talking to everything. It's all devices talking to each other in real time, in a secure manner. Now, it sounds great in theory, but what's the problem with this? To try and get Samsung in the same room as Panasonic, in the same room as Tesla, in the same room as Hong Kong Electric, to agree on a protocol, to agree on a common language, to agree on a common methodology, or even to cross borders regulation-wise, impossible. So IoT is a great idea, and it will happen, but it's struggling a bit, right? It's not moving along as fast as it potentially could be. What blockchain does is actually gives you that framework and that kind of common language and common space to communicate in natively. So what that means is that if I have blockchain powering my kind of IoT devices, I can now send not only instructions from one device to another, but I can also send transactions. If I can send transactions, if these devices can hold their own money, if they can hold their own value in the form of cryptocurrency, not necessarily fiat currency, but Bitcoin or Ethereum or even a native token, if they can make their own decisions based on the set of parameters that we give, then basically they become autonomous agents. And these autonomous agents, these devices, your car, your air conditioner, can make its own decisions about when to power on, when to power off. It can pay other devices. And one of the kind of most interesting, types of examples that I ever heard was this idea of the Google driverless car. Now, in the future, not very far future, the Google driverless car will be, the driverless car will be on the road, and there will be a lot of them. And ideally, they'll be able to communicate with each other. They won't necessarily need to kind of go through us to kind of turn on our blinkers. They'll actually just be communicating with each other. They'll know when each other is passing. Now, in this one example, a Google driverless car, for me, let's say I'm in a rush, I'm on the road, I need people to get out of the way because I need to get to work, and I'm willing to pay because my time is valuable. And so what I'm going to do is I'm going to instruct my car to pay off all the other cars in front of me to move to the left lane so that I can go through. And the car will be able to do that on its own because not only does it have the framework, the common language, the common pipeline to talk to all these other cars, because they're all on the same network, but it can also disperse its own currency. Now, it may not be worth $5 for me to get to work on time, but it's worth 50 cents. And 50 cents distributed along all of these other cars in front of me can be efficiently and cost-effectively distributed because now we're working with cryptocurrency, and I don't have to pay, a 3.5% kind of gateway fee to Visa. right? I can pay a fraction of a cent just for that transaction. So this is the type of thing which starts to become quite interesting for Internet of Things. And interoperable tokens is what makes this diverse set of actors empowered. How does it work? I'm not going to go so much into the technical side because I'm actually not very good at the technical side. But generally, it's a network. Blockchain is made up of a network of nodes, and this network of nodes runs all the same software. And as I said, it's the fact that every node on the network is running the same software, and they all have to agree with each other, is what makes it secure. If something doesn't agree, it gets kicked out of the network. And if you want to kind of corrupt the network or change one of these pieces of information or transactions in the blockchain, you actually need to attack the entire network, or at least the majority of the network. And while that is theoretically possible, and even technically possible, it's just very expensive. There was one estimate which said that if you wanted to actually corrupt the Bitcoin, which is the largest blockchain, you would actually need to spend over $40 billion just in hardware, just in mining hardware, in order to have a 10-minute window to change one of the transactions. And everybody in the network would know that you did it. And so it's not like it would be, a very stealth operation. So it's economically unfeasible or unadvisable to try and do this. The way that the blockchain works is when I send a Bitcoin to you, what's happening is I'm sending an instruction for a transaction to send value, a Bitcoin from address A to address B. And what that's then doing is sending and broadcasting that transaction to my local node. That node is going to collect a bunch of transactions, including mine. It's going to form it into a block, and it's going to attempt to apply it's going to attempt to solve a cryptographic proof, which will then solve that block. Once that block is solved, it's like a puzzle. It's then a race to try and broadcast that solved block to the rest of the network and have it be accepted by all the other nodes out there. If the other nodes accept it, and I kind of get there before everyone else, then that block becomes the next block in the chain. So all the blockchain is a block of transactions that are then kind of bonded together through a cryptographic solution, and that becomes the entire legacy of the blockchain. So a blockchain is literally an immutable history of all the transactions that have ever happened in that particular chain from day one. So that's why it's partially interesting. And that's the blockchain. What makes it different? It solves issues of trust enforcement of third parties. So once again, instead of having a government or let's call it Amazon or whatever type of corporate or non-governmental or even personal entity in between, you actually just have math and software. And ideally software which is visible to everybody, so everybody has the same transparent access to understand the integrity of the software. It's secure in the sense that it has no central point of attack or influence. That doesn't mean it's completely infallible. You can still hack me. And if I give away my private key, which is basically what happened in many of the well-publicized hacks in the Bitcoin world, when everyone says, well, what about Mt. Gox? How did they get all this Bitcoin stolen? I thought Bitcoin was very secure. Or the DAO hack. Oftentimes, it's either a flaw in the software which is on top of the blockchain, not the actual blockchain itself. For all intents and purposes, no blockchain has ever, well, like I say no, but none of the major blockchains have ever been compromised, meaning that their core protocol has never been hacked. And if you think about the Bitcoin blockchain, which has been around since 2009, and currently has a market cap of anywhere between $10 to $12 billion, it's not bad. It's not a bad record, this kind of 7 years of kind of integrity at such a high kind of valuation. Once again, it connects things very easily, disparate things, and it's relatively low cost and low friction. While the price has gone up for Bitcoin transactions to I think around maybe 20 cents per transaction, at one time it used to be as low as maybe 1 or 2 cents. So if I wanted to send $100,000 from Hong Kong to Chicago, I could do that in roughly 12 to 20 minutes for a cost of under 4 cents US. And that's pretty amazing considering in today's world, I would need to go to the bank, I would need to fill out a form, or at least sit there while they fill out the form and make sure that they do it correctly. I would then need to pay anywhere from 50 to 200 US dollars, including both sides, and I would need to wait anywhere from 3 to 5 days, making sure that it goes well, to transfer that $100,000. Forget about it in the regulation in case any transactions get flagged because, God forbid, I looked at the wrong website. So this is the type of kind of potential to free up assets and capital and value velocity that some of these things offer. It's important. Blockchain is important because it's a new paradigm for technology in our society. If you think about it, the internet is 50 years old. Around 1968 is when ARPANET was kind of first put together in a way, or a lot of the ideas. And that's 50 years ago-ish. And I think what we're playing for now with blockchain, it's not just about moving value from A to B. This is about the next 50 years and the next 50 years of foundation of technology that I believe, and I think many others believe, a lot of other technology will be built on top of. Again, it's that horizontality, and supply chain is just one of many verticals. Imagine what you could do if your supply chain was seamlessly, frictionlessly, and transparently integrated with many other kind of verticals: insurance, finance, geolocation, AI, let's see, everything else. That starts to become super interesting. How is blockchain used? I've seen some really interesting kind of startups, from my investor hat on. Just a few that come to mind that I think help you get your head around is Digix. Digix is gold on the blockchain. So they're taking gold assets, storing them in a vault, tokenizing that value, and basically freeing up that physical asset to be used in smart contracts, to be used as collateral, to be used as a stable coin to stabilize the value of other currencies. So that's quite interesting. RayDAO, they take flats in Singapore. They buy the flats, they lock them into a trust, and they tokenize them. So now I can buy one 100,000th of a flat in Singapore. Now, of course, I still wouldn't be able to live in it, but I would be able to use that asset for other things. And now having freed up that asset, I can lock that token into another smart contract and use it as collateral. I can use it as a form of guarantee or anything else. All the while that flat is still sitting there. Yujo is doing IP, intellectual property, so it's Spotify. So imagine if you had a song, which instead of being sold on Apple iTunes, is sold on Yujo. And when that money comes, when that $1.99 for that song comes in, it's automatically distributed to all of the royalty holders, rather than waiting maybe forever for that royalty to come through to the artist or to the producer. It will be automatically and programmatically sent in the form of digital currency. Imagine how much value is freed up when you start to make things more efficient and less friction. And when you remove some of the human elements that have vested interests in locking up that value, when you free that value, it creates a network effect of value. Other things, triple entry accounting is quite interesting. Programmable money is interesting. Obviously, Internet of Things, we can talk a lot about that today. Chain of Things is doing some great things. Chromaway is putting a Swedish land registry on the blockchain. So being able to have an immutable record of land, quite interesting, especially in countries where you can't take the government's integrity for granted. Supply chain management, of course, U-chain, block freight, low-cost remittance. Everybody talks about remittance and kind of value transfer in the Bitcoin and blockchain world. That's also interesting. And then finally, identity solutions. How does anybody, going forward, how will anybody on the internet know that you are actually you? Or have to find better and more flexible ways of identifying each other. And then finally, how about shipping? So I'll just kind of touch a few things. With the Internet of Objects, right? We talk about the Internet of Things. Internet of Things is where the things can actually talk to you. But how about objects that aren't networked? The ability to kind of tag them and track them starts to become very interesting. A good example is, that was given to me. I didn't come up with this example. Is Tianjin. After the explosion in Tianjin, I think they're still trying to figure out exactly what was there and exactly what was lost. Now, the actual objects. Obviously some of them were completely disintegrated, but the ability to actually know in real time would have been quite interesting. And now, while the blockchain wouldn't have prevented the tragedy that happened. What it would have done was actually lock the last known location, the last inventory for all of the inventory into an immutable chain, which would still be able to do reference today. Now it's hard to say where that is. Reduce shrinkage, which leads to lower insurance premiums, of course. Time saved with real-time data. If you could have real-time visibility and trusted visibility to all of your shipments and all of your inventory in real time, what else could you do with that time? And I think it's not just about cost savings, it's also about new revenue streams. Markets for everyone. When you can tokenize assets which were not kind of quantifiable before, when you can quantify time, space into a token, and then you can create a market around that token, and then you can truly find out the value of that token. So all that empty space and all these ships that are kind of floating across the sea, that may have value to someone, but the inability to actually quantify that value in an efficient way may be one of the, possibly, I don't know, maybe one of the impediments to actually monetizing. So, microinsurance on package delivery, we're actually already seeing this today. The ability to offer very, very small sums of insurance, as low as like $1 peer-to-peer on things like auto glass, things like your iPhone glass. These types of things are quite interesting. And then finally, even things like authenticity or organic is, okay, well, the elements that go into my vegetables are quite are organic. But even further, how do you guarantee that the land, how do you guarantee that all the elements that went into the elements are organic? You need to be able to track it all back. And when you have this immutable record and this kind of trusted, transparent type of chain of ownership, you can trace all the elements back ad infinitum. Obviously, this is all somewhat in the future, but we're not talking jetpacks here. We're talking about the next 2 to 3 years, and I think that's kind of the opportunity for what we're going to be talking about today. So thank you very much, and I hope you enjoy the rest of the day. Thanks.
Do you want to take any questions, Jehan?
Sure, if you've got time. If you have maybe 1 or 2 questions, I'm happy to answer them. Yes, ma'am. Okay, yeah, that's a good question. So you've tokenized, the question is, how do you reverse the tokenization of an asset? So you want to take, in some cases, the asset was never actually converted into a token. So let's take gold. I think gold is a pretty good example. And again, like Digix is the company that's doing it. So they buy gold. Now with an ETF, gold is a fraction, it's usually a fraction, right? If you buy an ETF, you're not actually buying gold, you're buying the representation of gold. And it's usually not a one-to-one representation, it's a fractional representation. And if you want to redeem that ETF, you can't actually. So you're not really buying gold, you're buying something, you're buying a derivative. Now, with Digix, what they're doing is, if I buy 1 gold token, it represents 1 gram of gold. They've already bought that gram of gold, and that gram of gold is, from a physical point and an auditability point standpoint, sitting in that vault, and I can audit that. Now, I can then, once that gold is in that vault, which they provide for me, they issue me a token. So I bought that token for the price of that 1 gram of gold. And then I can do with that token whatever I want. I can give it to you, I can program it into any type of smart contract anywhere in the world, because now that piece of gold can fly around the world and can do whatever I want with it. I can even split it up. So instead of being able to split 1 gram of gold to 1,000 parts, I can actually split that token into 1,000 parts with very, 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 very little loss of value. And very, very little transaction cost, because digital currencies are, by nature, very, very divisible, easily divisible. So to get that back into the gold, it depends on which type of asset, which type of company you're talking about. In the example of gold, if I wanted to redeem it, I would just send the token back and say, I want my gold, and they would give it to me. In other cases, it really depends on the individual process for marrying that token to the asset itself. And I think that's one of the challenges for you guys to figure out today. What exactly is the relationship between the digital token representation of the container, of the object in the container, of the ship? What is the collective kind of representation of it? And how do you formalize, or how do you secure that relationship? You guys have an additional problem, additional issue, I would say, which is the hardware side. But it's a good issue to have, and I don't think it's, again, it's not rocket science. There are many companies that are already doing smart containers, obviously, and it's just folding in that additional blockchain, which I think is the opportunity which is not necessarily available without the blockchain. So, kind of answering your question. Maybe one last question? Yeah?
Just a quick one. So, how can you guarantee that the different implementations of blockchain are actually consistent with one another? Because everyone's, it's at the end of the day software, and there are bugs.
Yep.
Like a message board like this, there are 5 billion implementations, all of them do exactly different things.
Great question. So the question is, how do you guarantee that the different implementations of the blockchain are consistent with each other? And so really this is a good question, which I think the root of the question is, how do I know which blockchain to pick? How do I know which horse, if a blockchain is a horse, to bet on? The answer to that is, if you'd asked me about a year ago, I would say, just try to choose the biggest one. But because the space, and again, let me give you a disclaimer. Like, blockchain is not completely ready for production, okay? Like, this is very much technology in development. So while I am very bullish on the technology, I'm not saying go out and convert your whole business to blockchain. I'm telling you that you should be looking at this, you should be investigating, you should be brave enough to try and make the types of POCs to actually learn through the process. But to answer your question, in today's world, I'm seeing, from an investor standpoint, a lot of efforts to bind chains together, such that I feel that within the next 5 years, it won't matter which chain you're on. Every chain will offer its own individual characteristics, whether it's speed, whether it's security, whether it's industry kind of specificity or access. Some chains will be permissioned, some chains will be public, but they'll all talk to each other. And the reason why I think this is because there are at least 4 or 5 implementations that I know of that are doing exactly this. One is called Polkadot, one is called Cosmos, one is called, Hyperledger to a degree as well. So I really feel that the most likely future is that there will be a bloom of chains, and that actually the chains themselves become commodified. And it will just be more about which chain do you use, which one is best for you, and it will be taken for granted that you can communicate between chains. So if I'm on Bitcoin with an application, I can send that transaction seamlessly and losslessly, let's say, to Ethereum, to Ripple, to Factor, to whatever chain you want. So I think that now you have to think about these things, but I think in the future you should be planning for a multi-chain kind of community.
Is there any alternative
Database. Is there any alternative to blockchain? It's a database. Blockchain is not good for everything. Blockchain is not necessary for everything, and one of the first questions that you should ask when you're looking at a blockchain project is, do I actually need a blockchain for this? And many times the answer will be no. And that's fine, because blockchain is good for other stuff. One of the tests I feel, again, for whether blockchain is appropriate is around diversity of actors. Some people will say scale, a number of actors. I actually think it's diversity of actors. For example, if many of the large conglomerates in Hong Kong have very diverse interests, everything from retail to transportation to hospitality to land, and it's, they're all the same company. But what binds them together is actually the base level corporate structure itself. The ability to kind of bind those all together and bind the information and kind of have both funds and information and strategy, whatever, seamlessly integrated is quite interesting. It doesn't matter how big that company is, it's how many different interests and actors are in it. So, anyway, thank you very much, appreciate it.